There are several physics questions that could be asked about this scene. Hopefully you thought through several yourself, but the most obvious question is, am I actually going to get to hit John with my car?
I certainly hope not. Anyway, there are a couple different ways we can go about answering this question. Take a moment now and plan out how you would solve the problem. Now there's a couple different ways we can go about solving this, but probably the most simple way is to measure the distance between myself and Tim's car, solve for the displacement mathematically, and then compare those two answers.
Why don't you go measure that distance?
Right.
From the video, we have the speed that I was going right as I slammed on the brakes, which was about 44 miles per hour. So that's what we'll use here in our calculations. And we want to know when I will come to a complete stop. So obviously my final speed will be 0 miles per hour. Once John brings us back the distance, we will almost have everything we need to find out if John would survive. So John, what did you end up with?
Looks like we got 63 feet and 1 inch.
The last material that we need is the deceleration of my car.
Now to find the deceleration of Tim's car, Tim brought it up to several different speeds 5 times each. Then he slammed on the brakes to come to a complete stop. I then went and measured the stopping distance. We put all those numbers into a spreadsheet, and using an acceleration formula, we found the average constant for deceleration for Tim's car. Now that you have all the materials that you need, you can now find out whether or not I get hit. First, we need to pick the right tool to use to solve for displacement. Now hold on, before you go picking any old equation that has displacement in it, let's think about what actually happened in the video. Since Tim was slowing down, his velocity was changing. Any change in velocity is obviously acceleration. Therefore, we're looking for an equation that has both displacement and acceleration. With these parameters, there's 2 equations that come to mind.
Now I know you may be thinking the first one is the obvious choice because we like to be lazy and displacement is already solved for. But if we think about the different materials that we have available to us, the second one has all of the materials that we measured. And by using algebra, we can rearrange the equation to solve for displacement. Now that we have our tools set up properly, we need to convert our units to make sure that we are consistent throughout. We now have an initial velocity of 64.53 feet per second and a deceleration of -33.70 feet per second squared. It's now just a matter of substituting and solving. When we do that, we get a displacement of 61.80 feet, which converts to a rounded answer of 61 feet and 10 inches.
Now that you have your answer for displacement, let's see how that compares to what actually happened.
Yes, let's.
I have no recollection of that ever happening. Not funny. Nobody likes you, Tim.
All kidding aside, let's see what really happened.
Hopefully your math already told you that I wouldn't get hit, but there's your proof.
But we need to actually compare our calculated answer of 61 feet and 10 inches to what actually happened. John then measured the displacement of the car to be 62 feet and 5 inches.
There you have it, folks. Math is again consistent with reality. I'm John.
And I'm Tim. Welcome to the real world of mathematics. Tetrahensive.
Because thinking is critical.